Hello, sir.
Welcome students to the new lecture on our Riemann integration. So in the previous lecture we have started the topic how to find the LPF and UPF. Okay, how to find the LPF and UPF. Okay, so LPF we know LPF is always your summation I equal to 1 to n mi delta I, okay, and UPF was your capital Mi delta I, okay. So today we will do some important theorems, okay, and as well as if we have some time, so we will start the topic that is Riemann integration also, okay. So let's do one more important problem. So question is, let f be, this is the next question, let f be the be a non-negative monotonically increasing sequence. Let f be the non-negative monotonically increasing sequence, okay, increase function, not sequence, function on the interval a comma b, okay, on interval a comma b, let p equal to x naught, x1, x2 up to xn be the partition of a comma b, these are the partition, okay, which divides the interval into n equal parts, okay, n equal parts, then show that UPF minus LPF, okay, UPF minus LPF, that is equal to B minus A upon N, okay, B minus A upon N, FB minus FA, okay. This we have to prove. This is like your theorem, okay. It is not a question, it is like a theorem. Now see, it is divided into n equal parts. Let h be the width of subintervals. Let h be the width of subintervals, okay. So we can find the width, that is, since n equal subintervals, okay. So let h is equal to b minus a upon n. This is the width of subinterval, okay. Since f is monotonically increasing function on interval a comma b, since it is function is monotonically increasing, therefore f is also monotonically increasing function on xi minus 1 comma xi. Okay, xi minus 1 comma xi. Okay, now mi, what is mi? Mi is your glb, greatest lower bound. Okay, greatest lower bound. Okay, so what is mi? Greatest lower bound, that is f of x belongs to xi minus 1 comma xi. Okay, since it is increasing, so what does it mean? At which point you will get the mi? At this point or this point? Just tell me. My question is, we have to find glp. There is interval has 2 points, xi minus 1 and xi. At which point you will get the mi? Yes.
Sir, xi minus 1.
Xi minus 1 or xi? Yes, Aryan says xi minus 1. What about the other students?
So xi minus 1.
Since it is increasing. Yes, it is increasing. Since it is increasing, so mi will be obtained at xi minus 1. Okay, Aryan, one question is, if function is decreasing, then at which point you will get mi, small mi?
Sir, xi.
Yes, Aryan says xi because it is decreasing. Okay, now means you have to find GLV because it is increasing. So see this one. This is the beauty of this function. It is increasing. Increasing means it has lower value and it has more value. Okay, so you will get the fxi minus 1 at this point. You will get the mi. Okay, fine. You will get the mi. So it means that this is your mi, xi minus 1. Should I raise it now? Yes. Should I raise it now?
Yes, sir.
1 minute,
Okay, what
sir.
about the
Last
students?
one.
Okay. Now see, we have to find capital Mi. Okay. What is capital Mi? Capital Mi is your least upper bound. Okay. F of x. Okay. Where x belongs to xi minus 1 comma xi. So where we will find the mi, capital Mi now?
Sir,
Upper
xi.
bound? Yes, Aryan says it is xi. So you will get there f of xi. Okay, f of xi. Now see what is LPF. Okay, LPF. What is LPF? LPF is summation I equal to 1 to n mi delta I. Okay, mi delta I. So what is mi? Mi small mi is your f of xi minus 1. What is delta I? Delta is your h. What is h? H is your b minus a upon n because width of subinterval. So you will put here I equal to 1, so it is f of x naught. Okay, so you will put f(1), f of x1, then f of x2, okay, so on f of xn minus 1. Okay, in this way you will get this LPF. So it is your b minus a upon n, that is f of x naught plus f of x1 plus f of x2, okay, plus f of xn minus 1. Okay, fine. This is your LPF. Now see, you have to find UPF. So what is UPF? UPF is always summation I equal to 1 to n mi delta I. Okay, so there is no delta, there is only h, that is width of subinterval. So it is f of xi, okay, into h. So you can see here it is b minus a upon n, okay. Then it is your I equal to 1, so it is f of x1 plus f of x2 plus f of x3, okay, plus f of xn. Okay, in this way you will get the UPF here. Now you have to subtract it. Okay, you have to subtract and get the answer. Okay, yes, subtract it and get the answer. Should I read it now?
Yes,
Okay,
sir.
Aryan say आ गया. Yes. Okay, so now you have to subtract it. So you will get here UPF minus LPF, okay, that is equal to B minus A upon N, okay, this is common. So you will get here f of xn minus f of x naught, okay. All these values will be cancelled, only this will be left here. So it will be b minus a upon n, that is fb minus fa. So in this way you can prove this theorem, okay, theorem, or you can say question number 1. Okay, fine. Should I erase it now? Okay, without erasing it, I will move to the next theorem here. Theorem number 1. This is the first theorem of your unit 1. Okay, unit 1. Theorem number 1. So theorem 1 says just 1 minute. Okay. Theorem 1 says let f be a bounded function on the interval a comma b, on the interval a comma b, okay, and let small m and capital M denotes the infimum, that is lower bound, infimum, and capital M as supremum, respectively. Okay, infimum and supremum, respectively, of f in A comma B. Okay, then we have to show then MB minus A less than equal to LPF less than equal to UPF, okay, less than equal to capital M B minus A, okay, for any partition, for any partition P of A comma B. This is the statement of this theorem. Okay, so we have to show that where if the function is bounded on the interval A comma B and let M, small m and capital M denotes the infimum. Infimum means your lower bound and capital M denotes your upper bound. Okay, for respectively for f in interval A comma B. So we have to show this thing. Okay, fine. Should I read it now?
No, sir.
It is all related to your bounded function. Okay, it is all related to your bounded function. If the function is bounded, then you have to show it is small m, and small m denotes your infimum and capital M denotes your supremum. Okay, should I raise it now? Yes.
सर इससे पहले जो हमने लिखा है सर
Should I
वो
raise it
अलग
now?
थी। सर इससे पहले जो हमने किया सर वो अलग थ्योरम थी या फिर
Okay.
ये पहली?
So let's see. So now see the proof. Let P equal to x naught. P equal to, yes, Aryan, any doubt?
सर इससे पहले जो हमने किया सर वो
A
क्वेश्चन टाइप
equal
के
to
अंदर
x naught comma x1.
सर आई एम ऑडिबल?
Okay, x1 comma x2 comma x3 up to xn equal to b. Okay, be the partition of interval a comma b. Let this be the partition. Okay, now see, and yes, that is also like a theorem. Okay, and mi, small mi and capital Mi be the infimum. I am doing these theorems because in the MST there will be no theorem, because your examination will be online. Okay, MCQ type. But for final exam, because your final exam is going to be held in physical classes. Okay, so for that you must do the theorems also. That's why I am giving the more stress on theorem this time. Okay, So these theorems may come in your exam. In MST2 it will be physical exam. MST2, because from 26th of March you are getting the physical classes. Okay, let mi and small m, capital M, small mi, capital Mi be the infimum and supremum okay, infimum and supremum respectively of f in xi minus 1 comma xi, okay, for I equal to 1, 2, 3 up to n. Okay, fine. So clearly, see this one. Clearly, mi is smaller than capital Mi. See this thing. Then it is also smaller than small m. Okay, rather may be equal to and m. Okay, now see, multiply both sides by your delta I. Multiply both sides by delta I. See this one, mi delta I less than equal to mi delta I less than equal to m delta I. Okay. Now see, take the summation I equal to 1 to n mi m delta I summation n equal to I equal to 1 to n mi delta I summation I equal to 1 to n mi delta I, okay, less than equal to I equal to 1 to n m delta I, okay. So this is your LPF less than equal to UPF, okay, less than equal to take m common I equal to 1 to n delta I, okay, take out small m common I equal to 1 to n delta I, okay. Now we have to show it is your MB minus A, okay, fine. Should I erase it now?
No, sir. अभी नहीं.
Yes, should I erase it now? Okay. So once again, I repeat, you have to show this is MB minus A less than equal to LPF less than equal to UPF, then capital MB minus A. Okay. So you can see here, take out M common, so it will be delta 1 plus delta 2 plus delta 3, okay, so on, plus delta n less than equal to LPF less than equal to UPF, okay, less than equal to M delta 1 delta 2 delta 3 delta n, okay. Should I raise it now? Yes. Should I raise it now? Yes. So what about other students? Okay. Now see, since your P in P partition is your A x naught, comma x1, comma x2, comma x3, so on, comma xn equal to B. Okay, so delta 1 is the width of first interval, width of first subinterval. Okay, what is the first subinterval? First subinterval is your x naught, comma x1, so it will be your x1 minus x naught. Okay, similarly delta 2, that is width of second subinterval, second subinterval. So it is your x1 x2, so it will be x2 minus x1. Okay, similarly delta 3, width of third subinterval. Okay, that is x2 comma x3, so it is your x3 minus x2. Okay, so delta n, that is width of nth subinterval. X n minus 1 comma xn. Okay, so it is xn minus xn minus 1. Now you can see delta 1 plus delta 2 plus delta 3 up to delta n. So if you add all these terms, only left value is your xn minus x naught. What is xn? Xn is your b minus a. Hence, you will get here mb minus a, that is less than equal to LPF. Okay, less than equal to UPF. Okay, less than equal to mb minus a. Okay, from this equation you will start your Riemann integration. Okay, from this theorem. Okay, hence proved. Okay, so in this way we can find mb minus a less than equal to LPF, less than equal to UPF, then less than equal to capital mb minus a. Okay, okay. Should I raise it now? Should I raise it now? Yes. Okay. So let's do one more theorem. Theorem number 2. Okay. All these theorems you have to do. Let F be the not for MST1 for your final exam. Let F be a bounded function on interval on interval a comma b, okay, and p be the partition and p be the partition of a comma b, and if p star, this is p star be the refinement P star be the refinement of P, then we have to show LP star F, LP star F that is greater than equal to LPF, okay, and UP star F that is less than equal to UPF. This we have to show, okay. Now see the proof. Refinement. What do you mean by refinement? Refinement means if P star be the refinement, okay, by definition of refinement, of the partition, yes, P is the subset of P star, means all the elements of P will be in P star, okay. So let P equal to A x naught comma x1 comma x2 xn equal to B be the partition of A comma B, okay, be the partition of A comma B, and Mi and capital Mi are the GLB and LUB respectively, GLB and LUB respectively of function f of x in xi minus 1 comma xi, okay, for I equal to 1 to n up to n, okay. So just simply I have given here the definition of refinement. P is the subset of P star. Let P be the partition A equal to x naught, x1, x2 up to xn equal to B. Be the partition of B. Then Mi, small mi is your GLB, capital M is your LUB. Okay. Should I read it now? Should I
Yes,
read
sir.
it now? Okay. You are feeling bored, but these all these theorems are very important. Okay.
Yeah, actually gini Sarah.
So now see,
Jam
as you know,
jam
what is LPF?
MI
LPF is your I equal to 1 to n mi delta I, okay, that is always less than UPF, okay, that is summation I equal to 1 to n mi
batch पे जी
delta
हाँ
I mi delta I, okay. Mi delta I, okay, where delta I, that is xi minus xi minus 1, okay. Now let P star contain one additional point. Very interesting thing. Okay, all the points of P, but one additional point. Okay, that's why I am considering it as a refinement. Let P star contain one additional point of division. Yes, one more point. Okay, means let P star is equal to A equal to x naught will be there, x1 will be there, x2 will be there, so on. Okay, xi minus 1 will be there, z will be there, xi will be there. Okay, then xi plus 1 will be there. Okay, so on, so on, so on, xn equal to b will be there. This is the part. This additional point is there. Okay. All these points will be given in your P, but P star have one additional point of division. Okay. Now see, let let mi dash, okay, let m1 dash, okay, small m1 dash, okay, fine, and m1, let m1 dash and small m1 dash be the LUB and GLB respectively, okay, for the interval of the interval of the interval xi minus 1 comma z, okay, and m1 double dash small m1 double dash be the LUB and GLB respectively for the interval of the interval z comma xi, means these are two intervals we are considering, this one and this one. These are the additional subintervals. Okay, xi minus 1 comma z and z comma xi, and where we are identifying here m1 dash and small m1 dash, lub and glb, and capital M1 double dash, small m1 double dash, bd, lub and dlb respectively. Should I read it now?
Yes, sir.
Yes, should I read it now? Okay. What about other students?
Yes, sir.
Fine. Okay. Now see. Since xi minus 1 comma z and z comma xi contained in the interval xi minus 1 comma xi. Okay, so this interval contained. Okay, now see glb of of f of x, okay, for xi minus 1 less than equal to x less than equal to z, okay, greater than equal to glb of f of x, okay, f of x xi minus 1 less than equal to x less than equal to xi. This we have to consider. Okay, and similarly glb of f of x z less than equal to x less than equal to xi is greater than equal to glb of, okay, f of x xi minus 1 less than equal to x less than equal to xi. Okay, and we are now we are doing just only for glb. Okay, therefore we have m1 dash, okay, m1 dash is greater than equal to mi, okay, and m1 double dash is greater than equal to mi. Okay, okay, now we have to calculate the lp star f, lp star f. Okay, so we will finish this theorem in the next lecture on Wednesday, because still a lot of part is left now. Okay, we will finish this theorem in on next Wednesday, in this Wednesday. Okay, so thank you very much for attending the lecture. थैंक यू।